participated in those, and they have a vaccine research expert group. There's TAG COVAC, that is what we're talking about today. And then when recommendations are made, the policy part is done by SAGE. So I'll first outline for you what our decision-making process is. So the committee was formed, I think, really by about September of 2021, we had our first meeting. And of course, at that time, we were talking about Delta. And so we went through to try to figure out what our decision-making process would be. And so the first part is done by the Technical Advisory Group on Virus Evolution, and they assess the features of variants of concern, transmissibility, spread, clinical severity, the mutations, and antigenic and vaccine changes in vaccine effectiveness. And from that point on, TAG COVAC picks up. And so this is what things looked like back in late November of 2021 when Omicron had emerged. And as you all well know, the Omicron BA.1 had many different mutations shown color-coded on this slide. It was highly divergent with a number of mutations throughout the genome, but particularly 26 to 32 mutations in the spike protein. Since then, of course, there have been several sublineages, many of which share some of these S protein mutations. And this, as I'm sure many of you have seen, is a reflection of the transmissibility and spread of Omicron. These are data this is a snapshot from next strain showing how from the beginning when Alpha dominated, followed, and that was replaced with the Delta strain, and then Omicron emerged. And at the time that we were talking back in June, BA.2 had become the dominant lineage globally. So the WHO the Secretariat put together a lot of information about vaccine effectiveness, and this is specifically the vaccine effectiveness of the primary series on the left and booster series on the right against Omicron. So I'm sure you cannot see all the details, but what we have here on the left are all the studies. And the first box is the effectiveness of the primary series of vaccination shortly after vaccination. The second box is 3 to 6 months later, and the third box is more than 6 months later. Each of these colors represent the different vaccine platforms. So what we saw from the primary series is that we had very good effectiveness against severe disease, and that's the top line. Below that are symptomatic cases, and below that are any infections. And what we saw was that there was some decline over beyond 6 months, and yet when we look at the booster doses, the boosters pushed the vaccine effectiveness up again. It is clear that the effectiveness against Omicron is best in protection against severe disease, and it is lower against symptomatic infection or any infection. However, the point to be made is that the currently licensed COVID-19 vaccines remain very effective against all of the variants of concern to date, including Omicron, when a booster dose is administered. So the question then was whether an updated composition needed to be considered because the variant of concern is sufficiently distinct from the strain that's been included in the existing vaccine. And so we have published two statements. We had published two statements, one in January and one in March. And the key messages were that the current vaccines may need to be updated. And we signaled that our committee was considering the strain composition of COVID-19 vaccines. So the next bit was data collected by the scientific community, many of you in the room, that were generating additional data on the variants of concern, including extensive antigenic characterization. Vaccine manufacturers and developers had made small batches of vaccines that they were testing. And what we were going to do is based on that assessment and the anticipated circulation or current circulation to see if in addition to retaining protection against severe illness and death, whether an updated vaccine would be needed to broaden the immune response. So we had a small subcommittee that we invited to provide additional input, and they're listed on this slide from There are virologists and immunologists that many of you know well, and some members of our committee itself. So we reviewed published and unpublished data, and the evidence base that I'm going to walk you through has 4 elements. We looked at the cross-neutralization and cross-protection data following infection with the index virus or prior variants of concern on vaccination. We looked at antigenic cartography, looked at preliminary data on Omicron infection, and preliminary data on candidate vaccines with updated compositions. So the first bit of data, this is a paper by Walls and colleagues. This was a paper that came out looking at showing that the number of exposures down here that are color-coded, and this is looking at neutralizing antibody responses on the left against the ancestral strain. So if we focus first on antibody responses to the ancestral strain, we see that the number of exposures to SARS-CoV-2 antigens, whether it is by vaccination, infection, or breakthrough infection, it is the number of exposures that results in a boost in neutralizing antibody titers. So one dose of vaccine or first exposure to infection gives you a very modest neutralizing antibody response that goes up with 2 doses or 2 exposures, further up with 3 or 4. Now, if you take those same sera and you test them against Omicron, and here we're talking about BA1, the 2 doses of vaccine do not produce cross-neutralizing antibody. But the 3rd or 4th exposure to SARS-CoV-2, whether it's by vaccination or breakthrough infection, gives you a cross-reactive response. In other studies, and here there's another publication where the Pfizer vaccine was given as a single dose, 2 doses, or 3 doses, and now you're looking at the neutralizing antibody response against a range of viruses, starting with the 614G virus, the Delta, Omicron BA1, and BA2. And what we see is that 1 dose of the Pfizer vaccine gives you a neutralizing antibody response against the original virus, a little bit of cross-reactivity to Delta, but not against BA1, and a scattered few against BA2. A second dose of vaccine improves the response to Delta and to BA2, but still responses to BA1 are pretty low. But a 3rd dose of the Pfizer vaccine, this is against the index strain, we see finally that there is cross-reactive antibody against BA1 and BA2. So we looked then at antigenic cartography, and these are data on the left that are, it's an antigenic map of SARS coronavirus 2 variants constructed from single exposure convalescent sera or double vaccinated sera. As you've heard from Derek Smith, the circles represent the viruses, the squares are the sera, and each of these larger boxes is a 2-fold change in titer. And you can see that the earlier variants, including the alpha, beta, and delta, and gamma, all cluster fairly close to the original index strain, whereas the Omicron BA1 and BA2 are much further out. And on the right-hand side is an aggregated antigenic map constructed from multiple preprinted published studies, and here you see BA1, BA2, and BA4. The 3rd issue that we looked at was the data that was available from Omicron infection. So at that point, we had data on BA1 and a little bit of data from BA2 infections. And the key point here is on the left-hand side. So we looked at what the response was in terms of neutralizing antibody in people that had an Omicron infection if they had never been vaccinated. So in an unprimed individual on the left, and this is an N of 20, what we see is that the Omicron infection induces neutralizing antibody responses to BA1 with some cross-reactivity to BA2, but very little cross-reactivity to the index strain or earlier variants of concern. However, on the right, in the B panel B, you see people that had been previously vaccinated. So these are previously primed individuals who, when they are infected with Omicron, BA1, have much broader cross-reactivity. So essentially what we're seeing is that the Omicron infection induces a very strong response that is to the homologous virus, but not a lot of cross-reactivity in unprimed individuals. But in primed individuals, you get the broader cross-reactivity. Similarly, and these are data looking at the cross-reactivity between BA1 and BA4 or 5, unvaccinated on the top panel in purple, and in vaccinated people on the panel below. So again, consistent with that other study, in primed individuals, you get a breadth that you don't see in unprimed individuals that have been infected with Omicron BA1. So the last bit of data that we had access to were data on the candidate vaccines with updated compositions. So a lot of this is animal data, so I'll talk you through as we go at the data from different species. And so these are the data from a mouse model, and these are mice that got 2 doses of an Omicron-specific mRNA vaccine, and we're looking at neutralizing antibody responses. So there are 2 different mRNA vaccines that were given. In red are mice, sera from mice that got the original 1273, which is the Wuhan-like virus. And in blue is the Omicron-containing vaccine. And so what you see is that mice that receive the Wuhan-based vaccine make a neutralizing antibody response to Wuhan with cross-reactivity against the Beta and Delta, but not against Omicron BA1 or BA1.1. However, in mice that got the BA Omicron-specific mRNA vaccine, you see the opposite. You see that they had good neutralizing antibody responses to the Omicron strains, but not good cross-reactivity to the others. Now, in the same mouse model, 2 doses of the mRNA 1273, which is the Wuhan vaccine, these mice were then boosted 10 to 11 weeks later with one of 3 possibilities. And so what you see here in the far left, again, these are neutralizing antibody responses. The first box are unvaccinated animals. The brown bar are mice that got 2 doses of the mRNA 1273, the Wuhan strain. So you get some antibody response against Wuhan. The middle bars are this part, the panels 3 and 4 are against BA1, and panels 5 and 6 are against BA2. So what we see is that the 2 doses of vaccine don't give you a good antibody response to Omicron. But now if you come back and give a 3rd dose of vaccine, and if it is the mRNA 1273, you boost the response to the Wuhan strain with some improvement in BA2 antibody, but not so much against BA1. But if you boost them with a Omicron-containing vaccine, you do see a good boost to the Wuhan strain, and now you're detecting neutralizing antibody against the Omicron variants. Data from the VRC at the NIH was done in macaques that had received 2 doses of mRNA 1273, and 41 weeks later, they were given either the mRNA 1273, which is the Wuhan-based vaccine, or an Omicron-based mRNA vaccine. The solid line, so these are neutralizing antibody titers done by 2 different assays, CEIRR taken 2 weeks after the boost. And what you see in the solid lines are neutralizing antibody responses with following the boost with the mRNA same vaccine, homologous vaccine 1273, and the dotted lines are those macaques that got the Omicron strain. So they argued that in fact you probably did not need to update the vaccine because we're detecting neutralizing antibody responses to Omicron that are in the same range. And they also, I should point out, that 70 to 80% of the B cells were cross-reactive against both the index virus and Omicron. But I will point out that these are data from 2 weeks post-vaccination. So Moderna had data that's been published using a bivalent vaccine that contained the Wuhan strain and Beta variant. So this bivalent booster, they gave it either as the, and they tested the sera from people that got the bivalent booster against, in blue, these are neutralizing antibody responses against the Wuhan strain, in green, against the Beta variant, in purple, Omicron, and in orange, Delta. And so what we see is our data from pre-vaccination is the first set of data, the second are 1 month out, and the third are 6 months out. And the first set are people that got the mRNA 1273 as an additional dose. It boosts the antibody responses, and these neutralizing antibody responses are maintained over 6 months. But in the second set of data are when the Omicron vaccine is given, either at 50 micrograms as a bivalent or 100 micrograms as a bivalent. And you could see that the response to the Wuhan strain is similar to getting just the Wuhan strain, but the cross-reactivity is improved against the Beta, Omicron, and Delta. And importantly, it is the 6 months post-vaccination data where you see greater durability of that cross-reactivity. Moderna presented data in people that got a bivalent Omicron plus index-based vaccine, again, mRNA vaccine, and they compared this to a fourth booster of the index vaccine. That's the light purple, the dark purple are the data from people that got a bivalent index plus Omicron vaccine. And these are data from all participants, from seronegatives and seropositives, and consistently the the titers were higher in the people that got the bivalent vaccine. These are neutralizing antibody responses against Omicron, and they maintained them the same pattern against the index strain. So to summarize that whole evidence base, what we had in June was evidence that Omicron was the most antigenically distinct SARS coronavirus 2 variant of concern to have emerged, and BA1 at the time appeared to be the most distant from the index virus. Antibody responses in previously naive, unprimed individuals exposed to Omicron showed strong but not broad neutralizing antibody responses. But in contrast, in people that were previously primed with SARS-CoV-2 infection or COVID-19 vaccination, broad immune responses were elicited following Omicron infection. So we felt that these data supported a preference for incorporation of an Omicron-specific vaccine product as a booster dose. We do acknowledge that we were missing quite a bit of information. We had minimal or limited data on cross-reactivity, both humoral and cell-mediated immune responses in vaccinated or unvaccinated individuals with breakthrough BA2, BA4, BA5 infections. We had minimal data on, over time, about Omicron infection in naive individuals and those who had breakthroughs. We only had data at the time on BA1 specific vaccine responses in both naive and primed animals. We had limited data on immune responses to Omicron vaccines. We only had data on BA1, and all of the limited data we had on vaccines was all from mRNA. So we put together a proposal at the time on updating the vaccine, and this was dated 17th of June. We believe that the continued use of currently licensed vaccines based on the index virus confers high level of protection against severe illness and death against all variants, including Omicron, with the booster dose. And that achieves the primary goals of the WHO vaccine program. But given the uncertainties of the trajectory of SARS-CoV-2 evolution and the unknown characteristics of where the future variants would be, we believed it would be prudent to achieve broader immunity against circulating and emerging variants while retaining protection against severe illness and death. So the available data to us indicated that the inclusion of Omicron as the most antigenically distinct variant of concern as part of an updated vaccine composition may be beneficial if it's administered as a booster dose to people who had already have received primary immunization with Wuhan. We did not advise the use of an Omicron-specific monovalent vaccine product as a standalone formulation because we did not know if an Omicron-specific vaccine would give us the breadth of cross-reactivity that we've seen with the original index vaccines. So for the Omicron-specific product, our committee recognized that viruses or viral genetic sequences very close to BA1 are some of the most antigenically distinct, And while we recommended an Omicron-specific vaccine product, this did not preclude consideration of other formulations or multivalent or bivalent formulations that would be the decision of regulatory authorities and manufacturers. So the take-home messages are that the TAG-COVAX, this committee's recommendations are not specific to any one country or region. We were making recommendations that would apply across the board. And it's very challenging because of the vaccine equity issues, and we really did not want to give out a confusing message about the existing vaccines. And so our goals are to maintain the protection that we have with the existing vaccines against severe illness and death, but broaden immunity. We're not trying to chase or match variants. And I think that's an important message. It is something that people think about as if for our flu vaccine composition updates, but we're really the goal is to try to broaden immunity. So as I said, vaccine equity remains a very significant issue, and decisions that are made in high-income countries will have consequences on vaccine acceptance and use of vaccine in lower and middle-income countries. So with this, I'm going to turn to David.
Thanks very much, Kanta. Thanks again to the organizers, excuse me, for organizing this and having us here at 8 a.m. following a brewery dinner. So that's excellent. I'm sure Marciela did it on purpose because she knows me very well. Okay, so I'm going to zip through this VRBPAC voting questions. So a VRBPAC meeting was held on June 28th, and that's an all-day meeting. It has public comments as well, and then the committee looks at their evidence and makes decisions. And so their question was, does the committee recommend inclusion of a SARS-CoV-2 Omicron component for COVID-19 booster vaccines in the United States? And so these meetings run, there's usually some epidemiology that's presented. This, my colleague Heather Scobie presented some parts from the COVID-19 task force at the CDC. I included this part of her presentation to remind all of you, this is in the United States where we have pretty good care post-infection. And I often hear, oh, Omicron's not virulent. It's not a big deal. Look at how many deaths, this is deaths in the United States caused by Omicron. And granted, that's because there was tons of infections. But imagine if Omicron, at an antigenic variant that it was, also had cleavability like Delta and virulence like Delta. Right? And so I think you have to think about that when you're thinking about new vaccines. So anyway, this is just to point out that look at how many deaths were caused by Delta. The red line is the 7-day moving average. And you can see what's happened by Omicron. And Omicron continues, right, until now. So anyway, this is data from our group at the CDC led by Bin Zhou. And what it is it's wild-type coronaviruses, or it's coronavirus, not pseudotype retroviruses. So it's a coronavirus, and it's a reporter coronavirus. So one of the genes is taken out and used for luciferase. And so you can see from going from left to right, all the different variants of concern, all done with the same protocol in the same lab to give you a sense of how far, what the fold change of the Omicron viruses on the far right are, with the Omicron BA1 and BA2 being so low. The fold difference from the wild type, which you can see on the far left, is 31-fold reduction for BA1 and 25-fold reduction for BA2. And this is from sera from humans that were vaccinated with Moderna or Pfizer, 10 of each. And so I would say a bit bigger antigenic difference than you're seeing on the cartography, which is often an amalgam of many studies and with pseudotype retroviruses. Okay, so here's some VE data. This is a nice graph that I pulled from the presentation that FDA gave to kind of summarize what's going on, so it's no longer out of Heather's presentation. But here you can see reduced effectiveness of current vaccines against Omicron variants. And so this is one of the big things for the TAG-COVAX committee and the VRBPAC committee, was to try to figure out, well, if it's still meeting the product profile of protecting against severe disease, why do we need to update it? there's many people in the vaccine field, they're not like flu people, and they don't think you need to update all the time. And so here you can see in the first bullet, the currently available vaccines do continue to be effective against severe disease outcomes caused by Omicron. However, vaccines' effectiveness against symptomatic COVID, which is shown below, due to Omicron is reduced. And so the blue line is real-world effectiveness against Delta. I don't expect you to see the numbers, but the very last point on the left-hand side, this is just after 2 doses, the left-hand side, the very last point is 270 days or more. And the second to last point is up to 270 days. So you can kind of look at up to 270 days, and you can see, it's in the 60s for Delta, and it drops very low for Omicron. And then with 3 doses, as we've seen with the serum, it brings up the immune response in the near term against Omicron, but it's still reduced compared to Delta. All right, so I'll breeze through this data because this was data we had in the TAG-COVAC, and Kanta showed it already, but this is the 1273 data that was shown 2 weeks later by Moderna at the VRBPAC. And so it's the bivalent vaccine. This is just different colors, but it's basically what Kanta showed you in that the 18 to 65-year-old group. Here we're looking at the 1273-214, to remind you, is a bivalent vaccine that contains BA1 and the index virus. And that's in the dark blue here instead of the purple that was shown earlier. But basically you can see good response, good induction of memory to the index strain on the left-hand side, so in both 18 to 65 and greater than 65. And on the right, it's against Omicron. And so you see strong boosting there and better reactivity against Omicron virus with the bivalent vaccine. Here, we're looking at the 4th dose sera against BA4 and 5. And so I don't think this was in the prior deck. So they had a little bit more time to look at this at this point in time. And you can see with no prior infection, the reactivity to BA4 and 5 is, again, pretty good. And it goes up significantly with prior infection. So again, we're seeing good boosting. Now I'm going to move to Pfizer-BioNTech. And so this was data really that wasn't available to the TAG-COVAC at the time. And so what you're going to see is really early time points in their data, just like 1 month after vaccination. And that's because everything had to be done, because basically July is when a decision has to be made to get a vaccine by the fall for the United States and other Northern Hemisphere countries. So here we have the clinical study to look at the monovalent and bivalent. So they had 3 doses of their original index strain, BioNTech 162b2, and then either a 4th dose at 30 micrograms or 60 micrograms, which is what's here, or a monovalent 30 or 60, or a bivalent 30 or 60. And I'm going to skip through a number of slides they presented, but just try to hit the ones that give us the main points. And here we're looking at Omicron BA1 neutralization, and is that it's substantially increased with Omicron-modified vaccines as the 4th booster. And so with the monovalent, you can see the geometric mean fold rise is 13-fold, and pretty good titers are induced against BA1. 60 micrograms is a bit better, but very similar. And with the bivalent, you saw a good boost. But clearly the monovalent looked a little better in this study. And they do a number of superiority and non-inferiority analysis as well. And the monovalent reached super superiority, whereas the bivalent just was shown to be superior. I didn't show you their analysis of that, but I wanted to tell you. So Omicron-containing modified variant vaccines as a 4th dose also elicited improved Omicron neutralization response. And here you can see against BA4 and 5 now that there it's reduced. So it's showing you the BA1 neutralization again in the dark blue, and the light blue is against BA4, 5. And just to remind everybody that's listed that way because both those variants have the same spike sequence. And so you can clearly see in folks here that they had pretty good responses with the Omicron at 60 micrograms and reductions against the BA4 and 5. The bivalent actually looked a little bit better. Next, they showed data, preclinical data in mice. So this is monovalent and bivalent booster vaccines in mice. And their argument is that the mice have looked very similar to what they've seen in human studies. It substantially increased Omicron neutralization responses to all Omicron variants, including BA4 and 5, and the reference strain. So again, here in the mice, and you can see this looks a little bit like humans, but your titers are very high, I point out. The Omicron BA1 neutralization here, and so this is the Omicron BA1 vaccine, and you can see the Wuhan, the index strain, BA1, BA2, BA2.12.1, and BA4 and 5. And so you can see the reductions here, but still pretty good immune response. Now, when they use a Omicron BA4-5 monovalent, you can see good neutralization of the better neutralization of the 4-5 and good cross-reactivity with BA2, which I think would be expected. There's not really that many differences between BA2 and BA4-5, but a little reduction against BA1 and good memory response to the Wuhan. Now here's the bivalent data. Again, a very similar phenomenon. Now, there's a number of other presentations, and then there's a presentation by Novavax, and I put this in here because I think it really illustrates kind of the confusing time we're in and whether, what you have to do for a vaccine, and potentially the different platforms have different impacts. And so the argument from Novavax is the vaccine doesn't really have to be updated. And this is a receptor inhibition assay, very similar to a neutralization assay. And you can see this is from their phase 3 trials, this dashed line, just so you can see how their titers were there. And with an 8-month boost of the same exact vaccine, they get good neutralization of BA1, BA2, and just a subtle reduction against BA4 and 5. And they go on to present some data, and it's summarized here, just boosting with the exact same antigen. And I should also mention it's an adjuvanted vaccine with something called like Matrix or M1 or something. The 2 doses, you can see very similar cartography, not necessarily the orientation, but about the full differences to what we've seen presented a number of times. But 3 doses starts to contract that circle so that now the BA5 is only 4-fold difference versus 9. And their 4th dose contracts it even further now, so there's just a 2-fold difference between index virus and BA4 and 5. So here's where we are today with the viruses circulating in the US. This was last Friday. It'll be updated again this Friday by our team. And Omicron's estimated at 100% of the circulating viruses, which has been true for quite a little while. You can see all the different weeks from left to right, with the most recent period being on the right-hand side, those last 3 bars. And at this date, the 13th, we had BA5 representing nearly 90% of the viruses circulating, BA4 really decreasing, and we recently split out BA4.6, which has a substitution at R346T and N658S in spike, which has been subtly increasing in the United States. And of course, there's a lot of work going on, and there's a lot of viruses out there. And one of the variants that the SAVE group knows well about, which we're a part of at CDC as well, is there's BA2.75. Right? And to Kanta's point about trying to match something that may be circulating in November, December, January of this year. Look at how many substitutions this has compared to BA2, many more than BA4 and 5 have compared to BA2. And it's in the US in very small proportions, but you can see the number of states it's been detected in. Globally, it's in 27 countries, with the most being in India, representing about 30% of the viruses from sequences dated back to the 23rd of July. And just 2 days ago, the first bivalent COVID-19 booster was recommended. Here, you can see this in the UK. And it's basically the vaccine that both Kanta and I showed you the data for. It's 25 micrograms of the index virus and 25 micrograms of BA1 component. So this is something that Kanta and I put together, is just what do we need going forward? A lot of this has worked in a very ad hoc way, many of you contributing lots of great data and things being published in, preprints and trying to collect all that data and understand what's reliable and what's confusing because of assays. And so we need global virologic surveillance. A few viruses may not be representative of the currently circulating strains, and they're not sufficient for assessment. We need virus sharing to accompany genetic sequence data. We need antigenic characterization linking genotype to phenotype, and this is critical. And it's really critical that these groups be able to compare their data very easily. And we need parallel evaluation in several reference labs, sharing viruses, reagents, antigenic characterization, and information. And then we want to end with some discussion questions for the group, and we can take it from there. Thanks. Great, Florian. Oh, it's not on.
I have a question for you. And this might be a little provocative, and sorry to put you on the spot. So Omicron was detected in November of 2021. Then we had the first really big BA1 wave in December, January here. We had a BA2 wave, we're now in a BA4, 5 wave, and maybe in September we're getting an updated vaccine. What are we doing to make that update so quick that it actually makes an impact on the wave when a new variant is coming that might have consequences? Because I'm afraid a little bit we're ending up as a system like for flu, where we are not responding to variants, but we're just updating every year, and then we might have the wrong vaccine again for something that is circulating. I think we might have a chance here to do better and to do things quicker. How do you think this could work out to get a vaccine into the population very, very quickly when something new shows up?
I leave the provocative ones to Kanta.
No, I'm going to hand it right back to David in a minute. I think that the emphasis really is on broadening immunity rather than matching or predicting what's going to circulate. So I think that back from our flu experience, we know that if you repeatedly vaccinate with viruses that are just a little different, you don't get a broadening of immunity. And so coming in with the booster, with the vaccine, with the virus that is quite antigenically distinct is our best chance at broadening immunity. So I think it is important to get the message out that we're not going to try, and I think it would be a mistake at this point because we simply don't know enough about the virus evolution for SARS-CoV-2, the trajectory, the direction of anything. And so really the emphasis is on broadening immunity. So I think that what we are doing will achieve that, and it may not be the exact strain, but the only experience we had was with the Wuhan strain. So to make a leap and say, okay, now let's do something else without any data would be very challenging. And I think we really needed some human data.
Yeah, and I'll just add, Florian, I think it's a great question, and I don't think it's very provocative. I think the entire system had to be set up to say, hey, we're going to change the strain. To this audience, it's very acceptable. But to many others in the vaccine world, it's not acceptable to just change the strain, right? And so now the system's in place. There's things moving forward. There's, as the regulatory agencies come in, you can see the decisions made in late June in VRBPAC, and likely they'll have vaccines, September, October, right? And that's their goal. So it's quicker than we have for flu, so you can delay it. But I think it's to this audience. What want to do to try to make it better, chance to make it better? And we can have a discussion. Next, let's go over here to Adolfo. I think it was next.
Okay, thanks. My question, is something to think about it. So I understand what is being done here and what tries to achieve. But what happened with the primary vaccinations, especially for the kids? The thing I still can see that would be Wuhan, Omicron. But how about Omicron, Wuhan? Or how to deal with the people that they don't have primary immunizations? What would be the vaccine recommendation for these people?
Yeah, well, I think that with the WHO recommendation, we were quite clear that people should receive Wuhan as their primary and then be boosted with Omicron. Now, more data would be helpful at Alpha where you do the opposite. But what we know and what we had was that Wuhan protects against severe disease. Wuhan's the progenitor of all the variants.
But it's the doses what I'm a little bit afraid, and when we just start with the actual circulating one or not, and if the studies can be done, because if you start with the actual circulating one, you have a better chance to have much better protection in the beginning after the primary immunization.
You want to take it? Yeah. I think it's an interesting point.
Yeah, so it is, but I think maybe a bivalent will get at that. And also, some of the manufacturers are trying to do studies in unprimed individuals with the monovalent Omicron to see if, in fact, we will get breadth if you come in and boost with the index. The recommendation has to be made based on data, and there are no data on, and our fear is that if you just go with Omicron first and come in and boost with Wuhan, we just don't know how that's going to, we have no data even from preclinical models.
My question is actually the same as Adolfo's, but I'm going to ask a quick follow-up, or just make a point on top of that. Given vaccine uptake rates, many people don't view the booster as part of the recommended series. So we've got a recommended primary series, and then the booster is sort of an add-on. And you can see that in the uptake data very starkly. Compliance with the primary series, but people not taking the booster. And so we may need to think about how we're presenting that plan, even just linguistically it matters, because people think the booster is optional, but if it's critical for broadening immunity, it really needs to be a primary 3-dose series.
Yeah, I totally agree. The communications it's a very important piece of all of this. And there's been a lot of loss of public trust. And there are large parts of the world that have not even had the primary series, much less the boosters. And in many countries that did very well with primary series, the booster uptake is not great. So we do need to message this very carefully. And at the WHO level, they're very concerned that if rich countries move to a bivalent or an Omicron-based vaccine, that no one will use the primary vaccine. So it is very complicated, and communications are critical.
I think we'll go back to the other side. Ron, no, to you.
Thanks. I first want to give a compliment to both speakers for giving an excellent talk after an excellent night out. It really shows that working hard, party hard is still working for us. My question is related to point 3 on this slide about data sharing, virus sharing, sample sharing. Of course, we all know what the problems are: is Nagoya and privacy issues, unequal opportunities for different countries. But what's happening at WHO and CDC to change that? Can we uncouple virus genomes from people's personal data to make this easier? Or is there any trick that we can use, because this is getting worse and worse? And for the next pandemic, we probably, if this is going on, we can't even share any single samples anymore. So is there any initiative to change this?
So obviously we can't speak for WHO, we don't work for them, we're not in all their meetings, but I think there is an interest at the WHO to actually challenge the status quo, Nagoya-related status quo, with COVID-19. So they do want to move this forward, and they want to use COVID-19 as a framework to do that. But that's just what I know from you. Limited.
Yeah. And so there's from the World Health Assembly standpoint, there's pandemic pathogen sharing work trying to go on to really push that forward and get all the stakeholders understanding that this is a global problem and we all need to do that. Decoupling the sequence data, I think, is really happening, so that's a good thing. Nagoya is in discussions about whether GSD, gene sequence data, is part of Nagoya or not, so that could impact it as well, because then you wouldn't be able to uncouple it. I think we could talk for all the time on it, but it's a good point, Rob. Let's go to Mike.
Yeah, great talk, both of you. I just wanted to say I was struck when you were talking about the data on and how the data on severity versus the efficacy of blocking infection is treated. And there's just this obvious point that if you want to block severe disease, you actually are doing a bad job of it if you're letting a whole bunch of people get infected. And it just seems to me, you kind of, if you're really thinking about, a situation where you don't want 500 people in the US dying every day, you have to integrate both of those and think of them together. And I know you guys are thinking of it, but it would be good to get the people, everyone on board with that discussion, because that's kind of the issue here, that we're behind the 8 ball in terms of protecting people from getting infected in the first place.
Yeah, I don't disagree, and also from a public health perspective, reducing transmission is likely also there, but hard to show. I'm going to go right to Mark too. Does anyone have a comment on that? Yeah, we'll go right to Mark next because he's been waiting patiently, and then we'll come back to that.
Thank you, Dave. This is directed to you, but I'd actually like to hear Kanta's comments as well. First of all, I'd like to second Ron's comments and add that I think it actually does something, because your lower voice, it really does instill confidence.
Yeah.
And I think it really does. It adds to the gravitas. So
thanks.
Well done.
Yeah.
Nice planning. But more important, my question, so you showed some really nice data that there is good protection with boosting, particularly when we start going to the bivalent vaccines and things like that. So we have, I could just say, effective vaccines if you want to look at disease severity and reduction and transmission to a certain extent. We have good antivirals as well. It's already, these viruses are spreading, I think, a little bit in the community level. When are we going to drop the biosafety level of this to, so we can actually get some work done and actually spend money more effectively?
So I agree with that as well, and we've done multiple calls all together discussing that subject. I'm in favor of that. Personally, I've been in favor of it for quite a while, and as part of the flu pandemic planning, we do have in the pandemic plan reduction from higher safety levels as part of the plan. So I don't know the answer to that. I work at CDC, but I'm not in that section of the CDC at all. And I think it's a good thing to have the research community start to voice this and decide, as a group, whether we think that's acceptable or not. In some of the conversations I've had, frankly, there were some researchers that were still against it, even after we had a vaccine and after we had antivirals. So that was interesting to me.
Yeah, so I'm not involved in any discussions about it, but I am very keen to have such discussions. It makes no sense to me to have this pathogen as a level 3 pathogen at this point. But when I've asked the WHO colleagues that I talked to, it seems to fall between the cracks. No one is taking ownership of it. So I think if one or more countries make a move, then others will follow.
I think we have missed opportunities because of this.
Yeah.
So because the resources, as we know, are shrinking, and that would be one way to extend those resources enormously.
Good point, Mark. Let's go over here.
I'm wondering if you can just say a little bit about whether there are any concerns about the trade-off for SARS-CoV-2 vaccination between breadth and quality. I mean, for flu with natural infections, I know we see polyreactivity and shifts towards epitopes that are conserved, but not necessarily as effective at protecting people from infection. So I'm wondering if you're seeing evidence for the same kind of trends with these vaccines.
I think it's too early to know. Data we have on the bivalent vaccines or any variant vaccines are very short in duration. So, and certainly the studies are not powered for effectiveness.
Yeah, and I would just add the things that I think really looked nice, and I'm not sure quality, I'm not sure it fits your question exactly, but if you really look at that data with the beta bivalent, the durability piece that we don't know with an Omicron bivalent is really impressive to me and a huge important factor. Let's go back over here. Sorry, Dylan, that was good.
Hi, Mark Mulligan, NYU and Crypt. Thank you. Nice summaries, nice talk. Question about the platforms that are used globally, and that mRNA data are driving these these next steps. But I think it's probably still true. Most of the world's not getting mRNA. How did your committees think about that, and what's actually happening? Are they also developing these next generation specific vaccines?
So I'll take it first, and then David can fill in. When we first met as a committee, we invited vaccine manufacturers, many of whom the flu vaccine manufacturers know the routine. They know that there'll be an information meeting where we announce vaccine strain composition changes. They're used to that. Many vaccine manufacturers making COVID-19 vaccines have not been in the flu field. So many of them were completely shocked at the idea that there'd be a strain composition change. And when they came to the meeting, they said, composition, what do you mean? And we said, strain. So, and I think the WHO invited 17 manufacturers, 5 came. So many just didn't even come to meet us to even hear about this. So it's an uphill battle getting all the manufacturers on board. Some of the manufacturers were already thinking about a Delta variant back in November of last year. But I think the mRNA is obviously the quickest platform and so on. So I think there are Chinese manufacturers that are making Omicron-specific vaccines, but we don't have a good sense of the landscape.
Thanks, Mark.
Yeah.
This is going to be the last question. We just hit 0.
So, is there anyone thinking about looking at what happens to people who are already infected with Omicron that are now going to get a boost? Because it seems that there is a large percentage of the population that's been exposed to Omicron around the entire world, and the whatever monovalent or bivalent boost they will receive will now be also a boost to their Omicron infection, which I think I've not seen anyone discuss or study.
There was a little bit of data on that, but what wasn't broken down was what they were infected with prior. And I think that, to me, the data that you're seeing, this is just now, we don't have data, but I think the data that you're seeing does indicate that you'll have good memory response to Omicron with an Omicron boost or in a bivalent setting. You know a lot about this, probably more than I do. So we'll see what happens, but I think it's probably pretty good. And obviously you'll boost some conserved epitopes that are Wuhan and Omicron.
So I'll just add that the scientific community around the world has actually produced the data that we considered. I mean, we're looking at published and unpublished data, or preprint data. The WHO is still working out what their COVID-19 program is going to look like once we're out of the emergency. So,
but to do these, you need to have the vaccine manufacturers run a study of that sort, because nobody has access to to running a trial that would give a bivalent or monovalent Omicron boost at this point.
True.
So last question, if that's okay. Is it okay, Dave?
Well, it's fine. You're the one you're the.
Yeah, but just exactly to the point that Kant was talking about, you all showed a wealth of data, and a lot of that data came from, the people in the room and the labs here, academic labs. And so, what is the role of academic labs versus industry versus, reference centers? What do you think we could build as a network to make sure we have the right data to keep making these decisions? Easy last question.
Well, I'll start. I just think that, I'm very biased because I think our flu system is extremely effective. And going through this, you could just see the difference that a coordinated set of labs that are really organized. So within the SAVE, I understand SAVE pretty well. You can see that labs group are coordinated. We have people with expertise selecting viruses, doing the testing, doing animal models. And that's basically what happens with all the CCs in flu. And it's going to have to contract because from my perspective, you can't keep doing this. The money won't be there. And it's been very ad hoc. It's almost been volunteering to do it and work hard, which thank you very much. But I think it will contract. And so that's why we have those questions up there. And so from my perspective, I think you do need a smaller set of labs that are sharing, as we pointed out, really sharing, not just doing the same virus. I've heard Omicron or BA1, but some of them have 346, some don't, some have BA 1.1. And so making sure that the same exact thing is being tested in multiple labs is really useful.
Yeah, and my pet peeve is the lack of antigenic data. So we have tons of molecular data. So we need more phenotype to genotype to phenotype correlations.
Thank you. Thank you both so much for coming to speak to us. So with that, we'll continue session 5. So if I can have the moderators come up, please.